Hello, ladies and gentlemen. So I've got a question as displayed on the board. You guys have to forgive me because I lost my camera stand, and now that's the reason why I haven't been making videos, because I don't have somewhere to place my camera as I will be demonstrating to you. But hopefully you are going to see. So it's going to be shaking a little bit, but what is important is for you guys to get the concept, right? Okay, thank you. So the question reads, a glass bottle of soda is sealed with a screw cap. The absolute pressure of the carbon dioxide inside the bottle is 2 times 10 pascals. Assuming that the top and bottom surfaces of the cap each has an area of 4 times 10 to the power 4 square meters, obtain the magnitude of the force that the screw thread exerts on the cap in order to keep the cap on the bottle. You are given that the air pressure outside the bottle is 1.0 times 10 to the power 5 pascals. So the question here wants us to calculate the force that must be exerted by the screw onto the cap so that the cap won't go out. Just a brief explanation. We all know that those of who have once drank, let's say Coke or Fanta from the bottle, the moment you open the bottle, you hear that fizz sound that says psst. So that's the carbon dioxide that we are talking about. There is carbon dioxide in the bottle. That's why we actually call them fizz drinks. So here the question is saying, given that we have got pressure that is being applied, so I actually had to break it down here. Let's look very closely here. So here you have got the cap of your bottle. Forgive me for my drawing. I'm not so good when it comes to drawing. So you've got the cap of the bottle here, and then this is the bottle, and then we assume that there is let's say there is soda here, and you know most that if there is bicarbonate of soda, there is absolutely going to be carbon dioxide. So the arrow that you are seeing here is the pressure or the force that carbon dioxide is putting on the lid so that maybe this can open. So this arrow is the arrow of the carbon dioxide, or the pressure that the carbon dioxide is exerting on the lid of the bottle. But for the bottle not to open, it must be screwed against the cap must be screwed against the bottle. So this is the cap, and it's screwed against the bottle, and the screw itself is applying a certain force that's downwards. But again, everything that is existing in the atmosphere, it's subjected to the force of the atmosphere, which we are calling Fa. So here we've got three pressures, or kind of three forces that are in action. The first one is the one that is being applied by the air, or kind of by the atmosphere, to the cap. And then we've got the force of carbon dioxide that is forcing out. And then we've got the force applied by the screw. So these three forces now, they are balancing this bottle. That's why the bottle cannot be able to open, because these three forces, they are balancing each other. But the moment you apply force and then you open the lid, that's why you hear psh, which means there is a lot of pressure inside the bottle, but that pressure cannot go out. Why? Because it's being balanced by the force that the screws are putting on the bottle, as well as the atmospheric pressure. Okay, so now for you to be able to calculate the magnitude of that force that the screw is exerting on the cap, you are asked to calculate the force that is being applied by the screw cap. This one. Remember, each bottle, when you are opening it, you struggle a little bit. Why? Because it's being screwed. The cap is screwed on the bottle. So that force of the screw is the one that they want you to calculate. So if you come here now, you will see then that I had to collect all the forces that are acting in y, because if you look here at our diagram, all the forces that we have, they are acting in the y direction. And since we said this bottle is closed, is tightly closed, it's not open, it means these forces, they are balancing each other. So as a result, all the forces that are in y-axis, which is the force being applied by carbon dioxide, which is this one, it's facing up. That's why you see here it's positive. And then the force that is being applied by the screw, which is this one, it's facing down. That's why you see it's negative with respect to the y-axis now. And then we have the force that is being applied by the air, it's also facing down. So at the end of the day, you have the force applied by the carbon dioxide minus the force applied by the screw minus the force applied by the air, which we can call atmospheric pressure. All these, they can give you a 0 because this is balanced. Okay, so if we are to take the force, since we are looking for the force that is being applied by the screw, we have to take everything else to the other side. So F screw is equal to F carbon dioxide minus F air. But we should know that pressure is equal to force per unit area. We all know this. So we need force. Here the information that we have, it's given in terms of pressure. So we need to make F subject of the formula. So if you do that, your F will be equal to PA. And then since the question told you that you are going to assume that the top and bottom surfaces of the cap each has got an area of this, which means the area for top and bottom is assumed to be equal. Therefore, you can actually factor out A. So if I do that, so here you can see most F screw is given by P carbon dioxide times A. P carbon dioxide A simply means PA means force. So P carbon dioxide A, it means the pressure being supplied by the carbon dioxide multiplied by area. So this is representing F carbon dioxide and this is representing F air. Since we agreed that F is equal to PA, which means where there is PA, it's as simple as saying F. But if you see P carbon dioxide A, it means the pressure that is being applied by carbon dioxide multiplied by the area, that will give you F carbon dioxide, and this will give you F atmospheric air. So if you factor out A now in both scenarios, you have your A here, and then you have your P carbon dioxide minus your PA. You are given all the information here. You are given that P carbon dioxide is that, and then PA is that, and then the area is that. So then you come here and you see me plugging in all that data. In place of A, I will put 4 times 10 to the power 4, negative 4, sorry. Then in place of P carbon dioxide, I will put 2 times 10 to the power 5. And then in place of PA, I will put 1 times 10 to the power 5. Remember these pressures there, SI units is Pascal. And then if you simplify what's in the bracket, you are going to get 1 times 10 to the power 5. And then you have got this A. If you multiply the two, you are going to get 40 pascals multiplied by square meters. Remember the SI units for area is square meter, and then that of pressure it's Pascal. But these are not done because you have got two different units here, Pascal, square meter. So we should know that 1 Pascal is equivalent to 1 kg divided by meter second squared. So every 1 Pascal that you have, it's equivalent to 1 kg ms squared, like this. So that's why you see me now coming and say 40, in place of Pascal, you see me writing kg ms squared. So all this simply means it's a Pascal. All this simply means it's Pascal. And remember here we've got times m squared, which is this one. So this m squared, if we can cancel one m there, it's going to cancel the other one, and then the units that we are going to have kg meter second squared, like this. Again, you have to know that 1 Newton is equivalent to kg meter per second squared. So in place of kg meter per second squared, you can simply come and put newtons. But it will be wise that each and every stage that you take, you indicate all this important information. So at the end of the day, this is going to be the force that the screw is going to exert on the bottle, so that it won't open. Hopefully you guys have gotten this. I tried by all means to make sure that I simplify and I then bring it as close as possible. I do not have a camera stand, so you guys should forgive me for all this. Thank you.